Hi everyone, this is your math guru. In this video, I'm going to show you how to solve the following Euclidean geometry question by applying various circle theorems. Please don't forget to click on the like and subscribe button below for more easy to understand math concepts. Diagram 1 of figure 1 represents three pulleys that need to be positioned to ensure effective movement of a conveyor belt. Diagram 2 is a diagrammatic representation of diagram 1. Angle BAC is equal to x. DEF are the centers of their respective circles. GH is a common tangent to circles D and E. The line IJ is a common tangent to circles D and F. Radii BD is equal to DC, which is equal to P, and radius EK equals to Q centimeters. Radius LF equals to Q centimeters. GH is parallel to IJ and BC is parallel to EF. MDN, EBD, and FCD are straight lines. We are to A, determine the size of angle E in terms of x. B, prove that BCFE is a cyclic quadrilateral. C, write down the length of EF in terms of P and Q. And D, prove that the line DE equals 2P cos x plus 2Q cos x divided by sine 2x. Going to the first part of the question that says we should determine the size of angle E in terms of x. I'm going to highlight angle E as shown in the diagram. Building up to finding the angle E, I'm going to start with the circle highlighted as shown. I have the angles inside. As shown, we've been told that D is the center of the circle, so therefore we have angle D1 equal to 2x. That's the circle theorem that states that the angle at center equals to 2 times the angle at the circumference. So I'm going to go back to the question and highlight the angle D1, that's 2x. Because we know that D is the center of the circle, the line DB and DC are equal. They are both radii. So we have DB equals DC. That's radii to the circle. Therefore, angle B2 is equal to angle C2. That's the basi angles of an isosceles triangle DBC are equal, such that we have angle D1 plus angle B2 plus angle C2 equals 180 degrees. The sum of the angle in a triangle add up to 180 degrees. Putting in the values, we have D1 as 2x, B2 is equals to C2, so I can call that B2 plus B2 equals 180. I have 2x plus 2B2 equals 180 degrees. Taking 2x to my right hand side, I'm left with 2B2 equals 180 degrees minus 2x, and dividing both sides by 2 to get the value of B2. I have 2 divided by 2, 1. So therefore, angle B2 equals, I can split this up as 180 degrees over 2 minus 2x over 2. 180 divided by 2, 90 degrees, minus 2x divided by 2, x degrees. From the question, we were told that the line BC and EF are parallel lines, and we can see that from the arrow. So therefore, because they are both parallel lines, the angle B2 is also equal to the angle at E, and that is equal to 90 degrees minus x, as we got here. The reason why angle B2 is equal to angle E, it's because they are both corresponding angles. We have a parallel line, so this angle is corresponding to this angle. Let's look at the second question. It says, prove that BCFE is a cyclic chord. So the first step is to highlight the quadrilateral. We have B, C, F, and E. So starting from B, I have B, C, F, and E. Is a cyclic chord. I'm going to start with the line DB. So we have question B. The line DB is equal to the line DC. I stated that earlier, and reason being they're both radii to the circle, and because they're both radii to the circle and they're equal, then the angle B2, I'm just stating what I stated earlier, is equal to the angle C2, and I have that as base angle of an isosceles triangle. I have B2 as shown in the first part of the question. That's 90 degrees minus x, and the reason why B2 is equal to C2 is about base angle of an isosceles triangle. So therefore, I have this angle, I'm going to mark that in the diagram, being equal to this angle, that's C2, and because we know that BC and EF are parallel lines, therefore the angle B2 is equal to the angle, therefore corresponding angle. So we know that B2 is equal to E, and already we know that B2 is also equal to C2, which is 90 degrees minus x. That's corresponding angle. So therefore, if you look at the straight line, the CF, what that means is the angle C2 is equal to the angle E. We've been able to state that in my last sentence. So therefore, BC FE is a cyclic chord, quadrilateral, and the reason is the external angle of a cyclic chord is equal to the opposite interior angle. So therefore, we've been able to show that. I'm going to clean all this so you can see where the proof comes in. The straight line DCF is given such that the angle C2 is equal to angle E, which is the interior opposite angle of the external angle C2. Let's look at the third question that says, write down the length of EF in terms of P and Q. So for the C part, we have EF, or the line EF equals, I'm going to highlight that, E2F. We know part of it to be Q, and Q, that's LF. We need to find the distance KL. Note that the distance KL is the same distance as MN. And we know that if you look at the diagram, the point D is the center of the circle. So therefore, the line BD is the radius, MD is also the radius, likewise DC is a radius, and DN is also the radius. We've been given the radius BD to be P, so we have line MD is also P, and the line DN is also P. So what we have here, KL, will be P plus P. So if I state that, I have line EF equals Q plus P plus P plus Q. So therefore, the line EF is equal to 2P plus 2Q. For the last part of my question, we have to prove that the line DE equals 2P cos x plus 2Q cos x, all divided by sine 2x. I'm going to draw out the diagram. That's the triangle EDF. So if I draw that as a sketch, I have triangle, I have D, E, and F. We know my D1 from the first part of the question is 2x, so I'm going to fit that in, 2x. I have line EF from the last part of the question, that's 2P plus 2Q. Also, angle E, I was able to calculate that to be 90 degrees minus x. So therefore, angle at F is also 90 degrees minus F. To find the line DE, as shown, I'm going to apply my sine rule. And my sine rule states that the side EF over the sine of angle facing EF, that's sine D, is equal to the side ED, that's the side I'm looking for, over the sine of angle facing ED, that's 90 degrees minus x. If I put in my values, I have EF 2P plus 2Q over sine D, that's sine 2x, equals, I have ED, that's the distance I'm looking for. I'm going to write that properly. I have ED over sine 90 degrees minus x. The next step is for me to cross multiply. But before I cross multiply, simplifying sine 90 degrees minus x, I'm going to have 2P plus 2Q over sine 2x equals ED over sine 90 degrees minus x becomes cos x. So from here, now I'm going to cross multiply, makes it easier. I have ED multiplying sine 2x, and I have cos x multiplying 2P plus 2Q. Dividing both sides by sine 2x, I have sine 2x divided by sine 2x, that's ED. Have one left, so therefore the distance ED, which is also, I can swap that to be DE to reflect what I have in my question. ED is also the same as DE, so I have DE is equal to, expanding at the top, I have 2P. What I mean is cos x is going to multiply all the terms in the bracket, so I have 2P cos x plus 2Q cos x divided by sine 2x. Thanks for watching. Bye.